one new chapter, waves. Anybody know about what is wave, the types of wave, what are the uses, anything related to waves? Kindly give me reply, ma. I'm waiting for your reply.
Sir, please repeat the question, sir.
Again, repeat.
Sir, please repeat the questions.
What is wave? Related waves, you know anything means you can tell me. In day to life, we observe some areas, waves. For example, throwing the small stone into the pond, there will produce the waves. And going to sea, there it is the waves it is. And a lake also, like in advertisement also you can see that lake also it is giving some waves slightly. So wherever we go, the waves is important. Okay, it is a our part of the life also. Waves it is. Sometimes you will think our waves. I'm thinking and you are thinking. So both also make merge together means so similar wavelength. Like that we are saying wavelength, waves like that. Same vibe. Yeah. So related waves general people know very well. But we are in science students, so we know more detail about waves. So in this chapter, we'll discuss related waves, all the terms and conditions. So just waves means it is a kind of disturbance. First I said no, the pond it is a before that it is very silent. Once you throw the stone, there is a disturbance. Due to disturbance only, the wave is producing. So wave means it is a kind of disturbance. Clear? We'll see one by one. Anybody know about the types of waves? Otherwise, any waves name. Already you learned in class ninth. In sound lesson, you learned waves, wavelength.
Sir,
Okay,
ultrasonic wave.
ultrasonic wave. Okay,
Longitudinal wave.
longitudinal wave. Very good. Next, electronic wave. Okay. Next, any others? Longitudinal. One more thing. It is okay. Motion of wave. It is a ray. Okay. Transfer waves. Very good. Asiba. Mechanical wave. Ham version. Good. That is ray. That is a kind of waves only. X-ray, UV rays. Okay. That is also the spectrum. Electromagnetic spectrum. Electromagnetic wave. Prasanna Kumar. Good. Sakina. Very good. Okay, so you know the maximum related to waves, but in this lesson, related to waves, the waves properties, and some derivative methods, and one more interesting topic it is there. In this lesson, very important topic also. That is the Doppler effect. It's important for the competitive exam as well as board exam. That one we'll discuss after. First, we'll start with the introduction part. Kindly watch the video. My voice is clear to you?
Yes, sir.
Okay.
Ever seen a Mexican wave at a sporting event? The effect is a pretty cool display that goes all around the stadium, but no one has had to move seats. All waves can transfer energy from one place to another without transferring any matter. This is done by a series of disturbances or vibrations that carry the energy. Just like the people in their seats only moving up and down when it's their turn. Waves can transfer energy through solids, liquids, gases and empty spaces, otherwise known as vacuums. There are two types of waves, which we look at in more detail in another video, but the basic features are the same. These four words describe different properties of waves. Let's discover what each one means.
Okay. We already discussed related all the things. Frequency, period, wavelength, amplitude. Anybody tell me one by one? What is frequency? Formula, otherwise SI unit, anything related to frequency.
F is equal to 1 by lambda.
Okay, next step. Mu is equal to think any
E is
other.
equal to H nu.
Mu is equal. Again repeat.
E is equal to H nu.
H nu, very good. Okay, nu it is next step.
Frequency is equal to 1 by lambda.
1 by lambda, 1 by lambda or 1 by t?
1 by t.
Okay, next period. What is the SI unit of frequency?
Hertz.
Hertz, very good. Next one, period. What is the SI unit? Wavelength.
Lambda.
Lambda is the symbol. Wavelength denoted lambda. Wavelength measured by meter. Period is measured by seconds. Next one, amplitude. That is the maximum disturbance. Okay, we'll see one by one.
Means. The frequency of a wave is the number of complete waves passing a fixed point in a given amount of time. This time period is usually 1 second. This is what one complete wave looks like. So if this was our time period, the frequency would be 5. Frequency is given the symbol F and is measured in units called hertz. Hertz measure how many complete cycles per second. So how many people in our Mexican wave stand up every second. The frequency and period are often confused. The frequency refers to how often something happens, whereas the period refers to the time it takes to happen. The period of a wave is the time for one complete cycle, so the time taken for one person to stand up, wave, and sit down. This would be measured in seconds. When something happens repeatedly, we say that the event is periodic, and refer to the time for the event to repeat itself. The period of the Earth to orbit the Sun is 365 days. The period of a day is 24 hours. The period of a typical class at school is 45 minutes. Now for wavelength. The wavelength is the distance between a point on one wave and the same point on the next wave. For example, two peaks or two troughs. Wavelength is given the symbol lambda from the Greek letter and is usually measured in meters. Wavelength can vary hugely in size. X-rays are very short, visible light is here, and FM radio waves are much longer. So we've looked at the frequency, period and wavelength so far. Let's finish with amplitude. As waves travel, they create disturbance. The amplitude of a wave is the distance from the maximum disturbance to the undisturbed position. Think of a very flat sea, and then an incoming wave. The amplitude is the height of the top of the wave from the flat sea. Can you add the labels to these waves and work out the frequency? Notice that the top one is distant.
Tell me the numbers. First one, second one, third one. Throw the chat box. What is first one, second one, third one? Kindly refer the diagram.
Sir, second one wavelength, sir.
Throw the chat box now. Type it fast. Yeah, first one correct, Asiba. Mukesh correct. Mukesh Kumar. Yeah, Prasanna Kumar, third one is correct. Mukesh Kumar, second one correct. That's all. Where is others? There is no reply from your side. Akash, Aparna, Chiradeep, Dharnidharan, Gautam, Gokul, Harsini Rajasri, Harsini, Janani, Lokesh, Kumaraguru, Manmohan, Mohanapriya, Anand, Navantika, Nivedita, Nivin, Sabari, Sitaranjan, Surya Sudarshana, Deshika. Okay. So we'll see the answer. First one, that is the amplitude.
And the bottom one is time. Pause the video, work it out and click play when you're ready. Did you get them right? In another video, we'll be looking at
Amplitude, wavelength, period. What is the frequency? The frequency is 41 second.
In another video, we'll be looking at wave speed equation.
Okay, now we go for the types of wave: mechanical wave, electromagnetic wave, matters wave. Mechanical waves, it is definitely needed for the medium. Without medium, it cannot travel. Okay, medium is important. It is required for the medium for the propagation. For the example, water wave, sound wave, etc. So this is the example of mechanical wave. And electromagnetic wave, those waves do not require any medium. Without medium, it can be travel. For example, light. So light is a electromagnetic wave. So no need to any medium. It will travel in vacuum also. Next one, matter waves, like matters, electron, proton, neutron, atoms, and molecule. So associated with the moving particle of matter. It is called as matters wave. The mechanical waves, it is a two type. One is a transfer wave, another one longitudinal wave. In this lesson, maximum we are discussing related in these two things. One is a transfer wave, another one longitudinal wave.
Waves transfer energy from one place to another. You should already know how to describe them in terms of frequency, wavelength, and amplitude, which we looked at in another video. In this video, we're going to look at two ways they can be classified. Waves are produced as a result of vibrations and can be classified as transverse or longitudinal. Whether they are transverse or longitudinal depends upon how the particles are made to vibrate as the energy passes. Let's look at longitudinal first. This is where the particles vibrate parallel to the direction in which the wave of energy is travelling. Notice that the ends of the slinky don't ever leave the hands holding them. It's only the energy that travels. The places where the coils or particles are bunched together are called compressions. Where they are furthest apart are called rarefactions. An example of longitudinal waves is sound. When a drum is struck, the drum skin vibrates, which causes the air particles next to it to vibrate. This causes the next air particle to vibrate, then the next, and so on until the vibration reaches the ear, causing the eardrum to vibrate. The vibrating air speeds away from the source, creating a sound wave. Let's look at another type of wave, transverse waves. The hand moves up and down, as does the slinky, but the wave itself moves from left to right. So the particles vibrate at 90 degrees to the direction that the energy is moving. We can simply think of it as, in longitudinal waves, the hand pulses horizontally, pushing and pulling, and the wave energy also moves horizontally, back and forward. Whereas in transverse waves, the hand moves up and down, but the wave energy still moves horizontally. Again, the ends of the slinky never leave the hands holding it. It's just the energy that moves along. Transverse waves are usually used to show the wavelength and amplitude. Pause the video and see if you can remember how to label the amplitude and wavelength on the diagram. Did you get them right? The waves on the surface of water are transverse waves. They make the water surface go up and down. All types of electromagnetic waves, like visible light, are also transverse waves. So, now you should be able to describe the differences between transverse waves and longitudinal waves. Remember, it is the energy and not the slinky itself that travels.
Okay, now time for taking notes. First of all, you can write start with new page. What is waves? It's a kind of disturbance. Otherwise, you can write in this statement also. The disturbance pattern which propagate through a medium by means of acceleration of a disturbance of the medium without any mass motion of matter is called wave. Next one, the types of waves: mechanical wave, electromagnetic wave, matters wave. So mechanical wave needed medium, electromagnetic wave no need medium, it will travel vacuum also. This is electromagnetic spectrum: gamma ray, X-ray, ultraviolet, visible red, infrared, radio wave, microwave. So matter waves means it is associated with moving particles like electron, proton, neutron, some subatomic particles, meson, pions, everything. Again, the classification of waves, there is a two type. One is a transverse wave, another one longitudinal waves. First, we will discuss one by one. What is transverse wave? The disturbance is perpendicular direction. Already you saw the videos, no? In this video, you know that the propagation is a perpendicular. Example, electromagnetic wave. So electromagnetic wave, electric field and magnetic field both also perpendicular. So only it is called as transverse wave also. Longitudinal waves, it is the same direction of the motion or propagation. The oscillation of particle of the medium is the direction of propagation of wave. It is the same direction. Kindly take a notes. So it is the crest and trough are formed for the transverse wave. For the longitudinal waves, that is a compression, another one rare refraction are formed. We see the picture in down. Next one, it is performed solid under surface of the liquid. It cannot perform in the inside the liquid and gaseous or the medium. But longitudinal waves, it will perform elastic of volume, bulk modulus of elasticity, like a medium, solid, liquid, and gaseous. There is no pressure changes For in this area, the pressure changes created in the medium during the propagation. Kindly draw the diagram, it is important. Transfer waves, another one longitudinal waves. Okay, next one, some important terms related to wave motion. This is a basic knowledge about waves. Amplitude, the maximum displacement of the particle of the medium from the mean position is called as amplitude. Amplitude. Define time period. One more time I'm asking, means no need to take more time. The time taken for the particle of medium to complete one oscillation is called as time period. Lambda means it is a wavelength, the distance between two nearest particles in the same base. That is the wavelength. Frequency, the number of vibration of a particle in one or equal number of wave passing through a point of medium in 1 second. First one, it is easy for you. The frequency nu, here the mention f, no problem. F is equal to 1 by t. And how to measure the frequency? Hertz. Otherwise, second inverse, CPS, cycle per second, RPS, revolution per seconds. This is also some other units of finding the frequency. Next one, angular frequency, omega. Omega is equal to 2 pi f. The SI unit of angular frequency, the radian second inverse, the angular wave number, otherwise propagation constant k equal to 2 pi by lambda, 2 pi by lambda. The SI unit of wave number, radian meter inverse. The statement wave per unit length. Wave per unit length. Next formula, velocity of wave, lambda by t, lambda into f, 2 pi f divided by 2 pi divided by lambda omega k. So all the formulas are related to velocity of wave. Okay. So up to that you take a notes. Related in this 2 point also you can note it now. It is also important. Longitudinal waves and the transverse waves. They cannot be polarized. That is the longitudinal waves. Can be polarized. That is the transverse waves.